So, why do things break? I mean, it seems like a simple question, right? But the answer, well, it's usually way more complicated than you'd think. Today, we're going to dive into a hidden cause of failure, one that costs industries millions. And we're going to meet the surprising hero property that can prevent it all. We're talking about tear strength. Okay, so let's set the scene. We're going somewhere where a tiny failure isn't just a small problem. No, it's a full-blown, costly disaster. We're talking about a high-stakes industrial environment where literally every single component matters. All right, picture this. You've got a production line just humming along at full capacity. Orders are flying out the door, the whole place is buzzing with energy. And right at the heart of it all, you've got this massive industrial oven, just cranking away at a blistering 200 degrees Celsius. Everything is going perfectly. Until it isn't. And then, boom, the entire line just grinds to a halt. And look, we're not talking about a minor annoyance here. This is downtime, this is wasted product, and it's a massive headache for the entire operation. So what's the culprit? What brought everything crashing down? It's this rip door gasket. Can you believe it? One single, tiny component just stopped the entire production line. See, with that seal broken, heat is just pouring out. Product quality takes a nosedive, and the whole process is totally compromised. Yet this little rip has just turned into a very, very big problem. So, how on earth did this happen? Well, the first thing people blame is usually wrong, and that brings us to the big myth we really need to bust today. I mean, think about it. If you're looking at something that failed inside a 200-degree oven, where's your mind going to go first? It's got to be the heat, right? And look, you wouldn't be wrong. Heat resistance is absolutely 100% critical. Of course you need a material that isn't just going to melt. But, and this is a big but, focusing only on the heat, that's like looking at a giant iceberg and only seeing the little bit sticking out of the water. It's a huge piece of the puzzle, for sure, but it is not the whole story. Because the real culprit, the hidden enemy that works hand in hand with the heat to cause these failures, is mechanical stress. These gaskets don't just sit there looking pretty. They live a hard life. I mean, they're constantly being squeezed and compressed. They're rubbed up against these rough metal frames. They get snagged by trays sliding in and out, and they get slammed in heavy doors, day in, day out. This is that human factor that so many people forget to account for. And this is where it all comes together. See, as that material gets hotter and hotter, its physical toughness just tanks. It gets softer, it gets weaker. So that tiny, almost invisible nick from the edge of a tray, it suddenly becomes a massive weak point. All that constant mechanical stress now has an entry point, and it just rips right through. So, okay, if heat resistance by itself can't save the day, what can? Well, it's time to meet the real unsung hero of material longevity. Let me introduce you to tear strength. Now, this isn't just about being strong, it's about being tough. Tear strength is basically a material's power to stop a cut or a nick from getting any bigger when it's being pulled or stretched. In other words, it's the exact property we need to fight back against this kind of damage. Okay, so we can actually break tear strength down into two key parts. First up, you have tear initiation. That's the force it takes to even start a tear in the first place, kind of like puncture resistance. But then, and this is just as critical, you have tear propagation. That's the force needed to keep that tear going. Having high propagation resistance, that's what makes sure a tiny nick stays a tiny nick instead of, becoming a total disaster. So that's all the theory. But what does this difference actually look like in the real world when the rubber really meets the road? And wow, this visual really says it all, doesn't it? Over on the left, you've got a gasket with a low tear strength. You hit it with heat and mechanical stress, and that small imperfection just explodes into a total failure. But look at the right. That's the difference high tear strength makes. Under the exact same conditions, it contains the damage. It holds the seal. It keeps the line running. That is our unsung hero in action. Now, this kind of performance, it doesn't just happen by accident. Oh no, it has to be engineered right from the very beginning. It has to be designed specifically for how it's going to be used in the real world. So, how do they actually do it? Well, it all starts with the recipe for the material itself, using reinforcing fillers that help it stay tough even when things get super hot. Then, it's about smart design, optimizing the actual shape of the gasket to spread out the stress and get rid of any obvious weak points. And finally, it's about formulating for the long haul, creating what you could call a damage-tolerant part that's really, truly built to last. And this really gets us to the bottom line, doesn't it? It's so easy to just look at the upfront price tag. But a cheap, fragile part that fails all the time? That's unbelievably expensive when you factor in all the downtime and wasted product. A properly engineered gasket that lasts even just twice as long? Well, that's a massive return on your investment. So, all of this, it really brings us back to one simple but absolutely critical question that you need to be asking. And it really all boils down to this. When one of your parts fails, are you really asking the right question about why? I mean, it's so easy to just blame the obvious thing, like the heat. But as we've seen today, the real cause of the failure is often hiding just beneath the surface. Because at the end of the day, the most important question isn't just can it take the heat, it's can it handle the stress. It's not about heat resistance alone, it's about tear strength. And understanding that difference, well, that's the key to stopping failure before it even has a chance to start.